Hey, this is question 2.2, patterned questions. They say that the sequent is quadratic, and they give you the first term is 3. But they tell you that t2 minus t1, which is the first term, equals 9, and t3 minus t2 equals 21. Now, I like to build, if it's quadratic, put down 3, t2, t3, like that. And I know that when I go t2 minus 3, I get 9. Well, the only way that can work is 12 minus 3. You can take this t1 equals 3 and just put it in t1 equals 3, put it in there, add 3 to both sides, just substitute and solve, and you'll get t2 equals 12. So that's what goes there. And by doing the same thing, if t2 is 12, put it in there, t3 has to be 33. But now you've got the whole thing. If that's 33, and that's t1, and sorry, that's the first difference there, second difference, which is 21. There's the first difference, which is 9. Well, if I subtract them, it's going up by 12 each time. So there's my quadratic pattern there. It goes up by 9, then by 21, then by 33. So all I do is I take my 33, add 33, and I get 66. And then I know it goes up by 12 more. Well, 12 more than 33 is 45. It's really nice to build this triangle so that you can work with it. 66 plus 45. The fifth term, which is the question they ask, must be not 110. It must be 111. That's really good. Why did I put 110? Let's just change that right now because I know it's 111. That's what 66 plus 45 is 111. So that's what it is. That should be an 11. Let's just put there 111. So that's the answer. It is 111 right there. Okay, now we've got that fifth term. Now they want you just to show that the sequence is 6n squared minus 10 minus 9n plus 6, if that's the formula. Well, you just play that game straight ahead. 2a equals 12, solve it, you get a is 6. 3a plus b equals 9, well, that's 18. Subtract 18 from 9, you get b is minus 9. And then add a plus b, 6 plus minus 9 is minus 3. You add it, you get c equals 6. Well, there it is. A is 6, b is minus 9, and c is 6. Okay. Now the next question, they say, show that this will be increasing, getting bigger and bigger. Well, we can see it's getting bigger and bigger, but can you show that it's increasing for all natural numbers? Well, increasing, if this was a function, and we took the derivative, it's increasing whenever this, well, first take the derivative, when this f prime of n is greater than 0. Well, let's look at this 12n minus 9. For any natural number, which is 1 or 2, well, 12 times 1 or 12 times 2 minus 9, they're always going to be greater than 0. And we can see that by putting any natural number in this formula, it's always going to be greater than, it's always going to be greater than 0. Because that's, in fact, if we solve this, we'd have n is greater than 3/4, and all natural numbers are greater than 3/4. It's just going to be true for all values of n. And I think that's what they wanted to do. Maybe there's another way to do it, but that's what I got.